Welcome to Brain and Beyond, where we explore the fascinating frontiers of human consciousness and neuroscience. Have you ever experienced a moment of extreme danger, like a car accident or a sudden fall, and felt as if time slowed down? As if your thoughts became sharper, the world around you moved in slow motion, and every second stretched unnaturally long. This phenomenon isn't just a cinematic effect or a trick of memory. It's a real and measurable shift in how the brain processes time under high-stress conditions. In this video, we'll uncover the neurobiological mechanisms behind this illusion, explore why the brain distorts time during emergencies, and what it reveals about human survival instincts and perception. Let's begin. Imagine walking near a construction site on a bright sunny afternoon. The air is warm, and the sounds of the city create a constant hum around you. You're probably thinking about what you'll have for dinner, or maybe replaying a conversation from earlier in the day. City sounds all around: the rumble of buses, the distant sirens, the chatter of people passing by. Your mind is wandering, drifting through thoughts and memories, not fully focused on the present moment. You're in that familiar state of semi-awareness, letting the world flow around you. Suddenly, without warning, you trip. Your foot catches unexpectedly on something uneven. It could be a cracked sidewalk, a loose paving stone, or even just an errant pebble. And you're falling. The ground rushes up to meet you, and a jolt of adrenaline surges through your body. In that instant, everything changes. Time seems to stretch and distort, as if the very fabric of reality has been altered. The world around you slows to a crawl. Every detail sharpens. The pavement's texture, usually unnoticed, becomes incredibly vivid. A crack, a jagged line across the gray surface, stands out with stark clarity. A discarded candy wrapper, its colors surprisingly bright, seems frozen in midair. It feels like you're falling for minutes, not seconds. Each moment expands, giving you an eternity to contemplate the impending impact. The ordinary laws of physics seem suspended. This isn't rare. Many people in danger report time slowing down. It's a common phenomenon experienced during moments of extreme stress or peril. A police officer once described bullets moving almost in slow motion, as if he could see them tracing their path through the air. This gave him time to think and act, to assess the situation and make split-second decisions that could save his life and the lives of others. Each second felt endless, stretched out like an elastic band, providing an unexpected opportunity for heightened awareness. A strange calm descends amidst the chaos, a sense of detached observation that allows for clearer thinking. But is time really slowing? No. Your watch ticks the same, relentlessly marking the passage of seconds at its normal pace. The world isn't changing speed, your brain is. It's a subjective experience, a trick of perception orchestrated by the complex machinery within your skull. This phenomenon isn't just for car crashes or shootouts. It's not limited to the most extreme and dramatic scenarios. It happens to climbers clinging to sheer rock faces, facing the constant threat of a fall. Surfers riding monstrous waves where a single mistake can have devastating consequences. Even children in danger, facing seemingly insurmountable challenges in their young lives, can experience this altered perception of time. It's a universal human response to fear, a deeply ingrained survival mechanism that transcends culture and background. The answer lies not outside, in some external manipulation of the space-time continuum, but deep within your brain, in the intricate network of neurons and synapses. In moments of threat, when your life is on the line, your mind shifts into a different mode, a state of heightened alertness and accelerated processing. Understanding this takes us into the secret workings of the brain, into the complex and often mysterious processes that shape our perception of reality. How does your mind build reality when survival is at stake? How does it prioritize information and make sense of the overwhelming sensory input? The answer is in the network of neurons inside your skull, the billions of interconnected cells that communicate with each other through electrical and chemical signals. What you experience is not a trick of the world, some external manipulation of time, but a trick of the mind, a clever adaptation designed to enhance your chances of survival. The illusion of slow time is a powerful clue to how our brains work, revealing the intricate mechanisms that govern our perception and response to danger. Let's explore how and why this happens, delving into the fascinating world of neuroscience to uncover the secrets of our perception of time. If you felt time slow down in a crisis, you're not alone. This subjective time dilation is common. Soldiers, parents, drivers, all report it. The pattern is clear. In danger, time stretches, giving you more moments to react. It's a core part of the human experience. But why does it happen? For years, people thought the brain sped up, processing more information per second. But the truth is more interesting. The feeling isn't about superhuman speed, it's about memory. Our brains aren't cameras recording real time, they're storytellers. In fear, the story becomes richer, more detailed. The key isn't what happens during the event, but how we remember it. Time dilation is a memory effect, not a perception effect. Our minds create a denser story, making moments feel longer in hindsight. To understand time dilation, that strange stretching of moments in crisis, we need to visit a specific region deep within your brain, the amygdala. This tiny, almond-shaped structure plays a crucial role in how we perceive and remember time, especially during moments of intense stress or fear. It's a key player in our survival mechanisms. Think of the amygdala as your brain's alarm system, constantly scanning the environment for potential threats. It's always on the lookout, a vigilant guardian ensuring your safety. This alarm system is finely tuned to detect anything that deviates from the norm, anything that could signal danger. When danger strikes, when a real threat is perceived, the amygdala doesn't hesitate. It instantly triggers the fight or flight response, preparing your body to either confront the danger head-on or escape as quickly as possible. This is an automatic primal reaction designed to maximize your chances of survival. It signals the hypothalamus, the control center for many bodily functions, to release adrenaline, a powerful hormone that surges through your system. This adrenaline rush has a profound effect, sharpening your senses, making you more alert and responsive to your surroundings. Your vision becomes more focused, your hearing more acute, and your reaction time lightning fast. It also works in close collaboration with the hippocampus, your memory center, the region responsible for forming and storing long-term memories. The amygdala tells your brain, this is important, this is critical for survival, remember everything. It prioritizes the encoding of this experience, ensuring that every detail is etched into your memory. In normal life, when there are no immediate threats, the alarm is silent. Your brain processes information calmly, methodically, and without the urgency of a life or death situation. But in danger, when the amygdala senses a threat, the alarm blares, your brain shifts into emergency mode, prioritizing survival above all else. It's not about thinking faster in a logical sense, but focusing all available resources, all your mental energy, on the immediate threat. The amygdala commands the brain to create a vivid, detailed memory of the event, a memory so strong that it can feel like you're reliving it in real time. Your senses narrow, attention sharpens, becoming laser-focused on the source of the danger, and everything else fades into the background, becoming a blur of irrelevance. This intense focus, this heightened state of awareness, fundamentally changes your experience of the event, warping your perception of time. The amygdala signal, this cascade of neurological events, is the first crucial step in making seconds feel like a lifetime, in creating the sensation of slowed time. It sets the stage, laying the groundwork for the illusion of slowed time, a trick of the mind that can have profound consequences. The brain's emergency mode, orchestrated by the amygdala, is ultimately all about survival and memory, ensuring that you not only survive the present danger, but also learn from it to avoid similar threats in the future. The secret to slowed time is in memory. It's a fascinating phenomenon, isn't it? How our perception of time can warp and bend, especially during moments of intense fear or excitement. It's not about perception in the traditional sense. It's not simply that time is moving slower. Our brains don't have a single clock ticking away uniformly. Instead, time is a construct pieced together from various sources. Time as we experience it is built from memories. The more memories we create, the longer a period feels. A day full of new experiences, packed with novel sensations and challenges, feels incredibly long in hindsight. It's as if we've lived a lifetime in a single day. Conversely, a boring day, filled with routine and repetition, vanishes almost without a trace. It's as if it never even happened. In moments of danger, the amygdala, the brain's emotional center, and the hippocampus, responsible for memory formation, work together in overdrive. They meticulously record every single detail of the experience. It's like the brain is creating a high-definition video of the event. Normally, your brain acts as a filter, sifting through the constant stream of information and discarding what it deems unimportant. But in a crisis, that filter is disabled. Suddenly, everything is deemed important, potentially relevant to survival. Every sound, no matter how faint, every color, no matter how subtle, and every movement, no matter how fleeting, is etched into your memory. This creates a dense, incredibly detailed memory trace, a rich tapestry woven from the threads of sensory experience. Later, when you recall the event, when you replay that memory in your mind, your brain interprets this rich, densely packed memory as lasting longer than it actually did. The event itself didn't actually last longer in objective reality. A stopwatch would tell a different story. Your memory just contains a significantly greater amount of information compared to a mundane event. The feeling of slowed time is therefore a retrospective illusion, a trick of the mind played on us by our own memories. You don't experience this slowed time in the heat of the moment as it's unfolding. It's only apparent later, when you remember it and reflect on the experience. So fear doesn't actually grant you superhuman speed or reflexes. It doesn't give you superpowers. Instead, it gives you something arguably more valuable, a powerful, vividly detailed memory of the event. This is a clever survival mechanism, honed by evolution to help us learn from dangerous experiences and avoid them in the future. Think of your memory like a camera. On a normal day, it takes 1 picture per second. In fear, it switches to burst mode, 10 pictures per second. The event is still 1 second, but you have 10 times the images. Reviewing them, your brain thinks more time must have passed. The density of information stretches your sense of duration. That's why accident survivors recall vivid details. The brain was in high-definition mode. The illusion is convincing because it's packed with sensory data. If our brains truly sped up, we'd perform tasks faster in emergencies. But we don't. Experiments show perception doesn't speed up. Only memory is enhanced. The world isn't slower. Your memory is just richer. This explains why time feels stretched in danger. It's all about how the brain records the moment. The idea of elastic time isn't new. William James in 1890 noted that varied events make time feel longer. Monotony makes it feel short. Early mountaineers like Albert von St. Gallen Heim collected stories of climbers who survived falls. They described calm, life reviews, and time slowing down. Heim's work was groundbreaking. He found these experiences were consistent in mortal danger. He suggested the mind enters heightened activity, altering time perception. These early observations moved the idea from philosophy to science. They showed time is subjective, shaped by emotion. Fear stretches and compresses our sense of time. This inspired future experiments to uncover the truth behind the illusion. Testing the memory density theory was tricky. You can't put people in real danger. So, researchers used the SCAD dive, a terrifying but safe freefall. Volunteers wore a device flashing numbers too fast to read. If brains sped up, they'd read the numbers during the fall. But no one could. Their perception didn't improve, even as fear peaked. Yet, they remembered the fall as lasting 36% longer than it did. Watching others, they estimated time correctly. Only their own fearful experience felt stretched. The results supported the memory theory. Fear creates richer memories, not faster perception. The illusion of slowed time is a trick of memory. The brain's emergency mode records more, making moments feel longer. On a normal day, your brain tracks time using many regions. There's no single clock. One theory, a neural pacemaker emits regular ticks, which the brain counts. Attention and emotion influence how we sense these ticks. When engaged, time flies. When bored, it drags. Emotions can speed up or slow down the pacemaker. But fear does something different. It shifts the brain into high-fidelity recording mode. Instead of just counting ticks, the brain grabs every detail. This makes our sense of time flexible, not mechanical. Our timekeeping system is built for survival, not accuracy. In danger, the brain prioritizes recording the threat over tracking time. That's why our sense of time can stretch or compress. It's a survival tool, not a stopwatch. After years of research, we know time slowing in emergencies is an illusion. The world moves at its normal pace. Our brains don't process faster. The amygdala triggers the hippocampus to record dense, detailed memories. The SCAD dive proved perception doesn't speed up, only memory is enhanced. We feel time stretched only when recalling the event. The illusion is a byproduct of our brain's survival system. Our experience of reality is a story, shaped by emotion and memory. Time is flexible, molded by our brains. The slowing of time in danger is a dramatic example of this. It's a powerful reminder, our reality is built inside our minds. What feels like time slowing down is really the brain speeding up. In moments of crisis, our perception stretches, not because the clock changes, but because our brain's processing power surges, helping us react, survive, and remember. From a sudden car crash to a near-death fall, the illusion of slow motion reveals just how complex and adaptive the human mind truly is. As science continues to explore consciousness, memory, and time perception, one thing becomes clear. Reality isn't just what we see, it's what the brain tells us we see. Thanks for watching this video on Brain and Beyond. If you found this fascinating, don't forget to like, subscribe, and share with fellow curious minds. And remember, sometimes the slowest moments in life are when your brain is working the fastest. Until next time, keep questioning what you think you know, because the mind is deeper than